Alright, hey guys. I'm sorry it took so long to get this review cracking off. You can watch this at your convenience. What else do I want to say? This is something, I included things in the question stems that you'll see again in neuro, so I hope this will be helpful to you come next year and the following year as well. I apologize for the ambiguity in some of the questions, like number 1, for example. That's why I incorporated a lot of bonus points to account for, my first time writing exam questions and et cetera, et cetera. Anyway, number 1 was asking what the areas are called that include the neuronal cell bodies. So the answer was gray matter, right? Remember, white matter is tracks, and it's white due to the myelin. Dark matter makes up 95% of the universe, but not neuronal cell bodies. And C sounds like something that fake scientists like Richard Dawkins would say. 2, smooth muscle. Almost everyone got this right. Good job. Myosin light chain kinase. Calcium is needed for both skeletal and smooth. Voluntary is skeletal. T-tubule is skeletal. And nicotinic acetylcholine receptors are skeletal. 3, this one was one of the more challenging ones I included. The answer is actually C. This was trying to get at the concept that even though the same neurotransmitter exists, it can have completely different functions depending on the type of receptor. So I was asking why dopamine can have one function in the direct pathway, yet an opposite function in the indirect pathway. So the only answer that makes sense is C, because it's the only answer that includes opposite functions, right? If there is activation of vanilla cyclase versus inhibition, those are opposites. And this would be via the D1 receptor, and then this was D2. Even if you didn't know this, you could just use the process of exclusion. So this is just random. You should know that's wrong. Both pathways contain the D1 receptor. If that were true, they wouldn't have opposing functions. D, this is describing just the general functions of the basal ganglia. And E is super random. Okay, 4. This was getting at equilibrium potential. Resting membrane potential will move toward the equilibrium potential of an ion, given that it's selectively permeable, or given the membrane is selectively permeable for that ion only. All the rest were just distractors. Number 5, myasthenia gravis. So this was one of those that kind of had a little bit of fluff, right? So you can ignore a lot of it and go to the question. So where in nicotinic acetylcholine receptors seen? The answer is A. Sweat glands have muscarinic receptors. Acinosos in the heart, they can have like adrenergic or muscarinic, but not nicotinic. Large intestine is usually known for parasympathetic activity, so a lot of muscarinic. And E, both A and B are true, is wrong. Sorry if I confuse you on this one, because I know in class I even got confused and thought sweat glands were nicotinic, but they're definitely not. They're muscarinic. Sacculoneutral. Okay, so I was just asking you to remember that the vestibular system relies on mechanoreceptors. Chemoreceptors, remember, is like olfaction, like in the nose. C would describe the ALS. D is vision, obviously, and then E is trip V1. That's what that's describing. Seven. So I show you their dorsal columns are knocked out. So immediately you should be thinking PCML, and you should be thinking fine touch, proprioception, vibration. So on physical examination, you would expect inability to distinguish on 2-point discrimination tests, because that test, fine touch. This is pain, test pain, so that's wrong. Ataxic gait, you might see, but that more is testing the cerebellar function and fibers that go to the cerebellum. Hyperreflexia would be an upper motor neuron sign, so that's wrong. And then absent pupillary light reflex is nowhere near this area, so that's wrong. And remember, so like D is not right because the spinal cord is divided to dorsal and ventral. Like most of the sensory information is up here. Most of the motor information runs down there. There is some crossover, but just as a general rule. Okay, this was describing polio, and polio is a pure lower motor neuron disease. I give you all lower motor neuron signs. Hyporeflexia, fasciculations are only seen in lower motor neuron injury, and no toe extension. So that means that the Babinski is normal, right? Because if the toe goes up, that means it's up an upper motor neuron, but I tell you there's no toe extension, so the answer is E, pure lower motor neuron disease. 9, I was trying to get at the concept of simple diffusion, and simple diffusion follows its concentration gradient. Transport maximum, B is wrong because the only way something can reach a transport maximum is if there's a transporter, right? And simple diffusion doesn't have a transporter. This is really famous for the glucose, sodium glucose cotransporters, SGLTs. Can directly or indirectly use energy? No, because that's like primary or secondary active transport. Moves against its concentration gradient. No, that is also active transport. Uses public transportation and Lime scooters. If you would have put that, I might have given it to you. Just kidding. Okay, olfactory nerve. So I wanted you to hone in on C fibers. They're unmyelinated and small nerve diameters, so they conduct very slowly. And the ALS uses C fibers. PCML, remember, is A alpha and A beta. Okay, single most important factor for establishing potassium leak channels. Reiterated that several times, so I'm not going to go over that too much. Number 12, during depolarization, so action potential, upstroke, right? Depolarization. So resting is around -70, and you're getting less negative during the upstroke. Both A and D are definitely wrong because potassium's like equilibrium potential is like -90 and chloride's like -75, so it's definitely not moving in those directions. 13, pretty straightforward. Hope everyone got that right. I think everyone got that right. Where does the corticospinal tract decusate medulla. Remember the cervico-medullary junction. This one was a little tricky, but I did tell you motor and I told you face. So remember the homunculus, the creepy picture, and the face dangling over the side. So this is the cerebellum, and that'll help you in like neuro lab especially. Whenever you see the cerebellum, it's posterior. This is anterior. To orient yourself, this is the central sulcus down here. So this red area is the motor, primary motor cortex. This blue area is primary sensory. And I told you motor, right? So even if you didn't know where the face exactly was, B is the only answer that makes sense. C would be pointing to sensory area, for the legs, let's say, like around lower limb, trunk. E is pointing to Broca's and Wernicke's. Broca's, Wernicke's. A is just part of the, probably association area or something, frontal lobe. D is primary visual cortex. Anyway, B is the right answer. 16, first order question. Increase in cyclic AMP, GS, right? G stimulatory. Upstroke of an action potential, right? So what's happening here? Sodium rushes into the cell. What makes a chemical gradient? C for concentration, right? C for concentration. Answer is B. This would be water movement. So this is describing osmosis. This also has osmosis in, so A and D are wrong. Hypothalamus is like a lot of sympathetic control. Oh, and E is describing electrical gradient because it's talking about charges, right? 19, I was basically trying to ask what ions are important during repolarization. You'll see amiodarone so many times. It's almost annoying. It causes a lot of nasty side effects too. Anyway, blocks potassium channels. Any type 3 antiarrhythmic, like amiodarone, blocks potassium channels, prolongs the repolarization phase, and you'll learn it can cause something torsade de pointes, and it's a very lethal arrhythmia that is a side effect of those medications. Okay, so Romberg tests, they start to sway. So Romberg test is positive, proprioception is affected. PCML, proprioception. Interneurons can release excitatory or inhibitory neurotransmitters. Which of the following is inhibitory? GABA is the only one there. Glutamate's excitatory, and then the other ones are just distractors. 22 is talking about sensory transduction, and I highlighted this several times in my lectures. The term for conversion from an environmental stimulus into an electrical signal in the form of an action potential happens all throughout our nervous system. Sensory transduction. 60-40-20 rule. 40's I, CF, and 20% is ECF. So it's A. '24 is talking about sodium, and it's not that because I tell you it's a positively charged ion, and I tell you that it has a very strong gradient to move into the cell, and sodium's the only one that has like a really strong gradient to move into the cell. trying to think. That's all I really want to say about that. That one was a little tricky, so 25. Why do we have sodium, potassium, ATPase pumps? You had to pay very special attention to the wording. Am I talking about outside or inside the cell, high or low concentration? The answer is D. I think it was D. High concentration because the pump pumps 3 sodium out the cell and it pumps 2 potassium inside the cell. So we would have a high concentration of sodium outside the cell and a high concentration of potassium inside the cell. What neurotransmitter is responsible for muscle movement? That one is pretty straightforward. Celiac ganglia, we're talking sympathetics. Upon eating a giant meal. So whichever answers you would see during parasympathetic dominated state are correct. So you would definitely see decreased activity of a sympathetic ganglia, and you would see increased secretion of stomach acids because that's rest and digest, right? So both B and C are true. 28, where would you expect to find the preganglionic neurons for a sympathetic pathway? So this is thoracolumbar, right? That's the sympathetic system. The only answer that has anything in the thoracolumbar region is A. All the other ones are wrong. Okay, I think almost everyone got this right. 11 out of 11. So good job. It was long and short. Long and short. 30 was M3 receptor. I tell you it's smooth muscle, adducer muscle. So when it's relaxed, the M3 receptors are not activated, and then when it contracts, like remember, like urination, defecation, it's like parasympathetic activity, rest and digest. So we know it's not nicotinic because it's smooth muscle. Beta 2 would be sympathetic. Ligand-gated ion channel would be describing a nicotinic receptor. And then you just had to know you were down to 2, M3 or M1, and the answer is M3 in the bladder. Beta 1 in the hot. Most people got 31 and 32 right. Good job. If you wanted to, you could have just came down here and looked at which receptors is atropine block, and it's muscarinic. If you didn't know that, you could read the question stem and figure it out, because I tell you that there's too much parasympathetic activity. This is cholinergic toxicity. And I tell you they administer both atropine and 2-PAM. 2-PAM takes longer to take effect because the regeneration of the acetylcholinesterase enzyme takes a little bit of time, but you need immediate symptom relief. So you want to stop the parasympathetic activity now. So A is the only one that makes sense. Okay, peristalsis, rest and digest. I'm asking about a state of increased peristalsis. This is sympathetic nervous system. And I said post, so that doesn't even make sense. It was tricky a little bit because I was talking about pre-ganglionic neurons. So B is not correct. The answer is C, because remember they have their post-ganglionic neurons in like an intramural ganglion or really close to the target organ. This was describing sympathetics as well, D. Most everyone got this right. Acetylcholine, functioning as part of the sympathetic nervous system, but using acetylcholine and nicotinic receptors. And this, if you're paying close attention, could help you answer an earlier question. 36, I'm asking about beta 1 blockade. You know beta 1's GS, so if you block a GS pathway, you're blocking a GS pathway. So A is the correct answer. 37, IP3 and DAG. Remember those buzzwords: phospholipase C, smooth muscle, GQ pathway. 38, A. Okay, so I'm telling you a diabetic patient has their blood drawn. And remember, blood is telling you what's happening in the ECF. They have high sodium and high glucose in the ECF, and sodium and glucose determine the osmolarity. So the solute concentration is very high or hypertonic in the ECF. Water, to equal everything out, will move from inside the cell to outside the cell, so from the ICF to the ECF. And that's why diabetics have to pee a lot, right? The high glucose is pulling the fluid out into the extracellular fluid that's getting filtered by the kidney and then goes down the ureter into the bladder, and then they have to pee a lot. And they're really thirsty all the time. So that's why. This was straight memorization. Facial nerve, the nerve to stapedius, and stapedius muscle. 41. I think everyone got this right. I hope everyone got this right. Optic chiasm. Remember bumping into things, the bitemporal hemianopsia. This woman actually has a pituitary adenoma, and it's grown so big that it's hitting the optic chiasm. So like the endocrine symptoms are related to the pituitary adenoma. Okay, cranial nerve 2, afferent limb. 43, good job on this. A lot of people got this right. This was a little challenging. So if you remove an inhibitory effect on an inhibitor, you almost will always end up with excitation. So you can immediately cross off B and C, and then you're limited to 50-50 shot. If you remember, the basal ganglia results in excitatory information sent from the thalamus to the cortex. You got the answer right. D, I just threw in like random parts of the basal ganglia. So is wrong. Hopefully that made sense. 44. Okay, so where do the knife slice? Remember, like, if this is the spinal cord, the knife is like, it's a horizontal slice, right? And I should have made that more clear, but it's not like somebody's getting stabbed vertically. So hopefully that didn't confuse you. But even if it did, you should know from the symptoms: pain and temperature in the right leg. So you knock out ALS, you lose at PCML in the left leg. Ipsilateral symptoms of the PCML tell you which side the hemisection is on. So it'd be the left half of the spinal cord. So the cut, it would be like, let's say if this is right, this is left, be like that. And remember, the reason you get contralateral loss of pain and temperature is because the ALS information crosses over immediately. Okay. And then the PCML stays ipsilaterally. Which of the following clinical tests would be used to test the functionality of the PCML in the lower limb? So the only thing that makes sense is testing vibration on the medial malleolus. Pinprick is pain. 2-point discrimination test on upper back is upper limb. So that's wrong, and the reflex is not correct. 46. This was a little challenging, but I tell you they have monocular blindness, so only one eye is affected. So you know it can't be any of these because all of those affect both eyes. Now you're left with choosing between A and B. So this was a case of retinal detachment. If you get punched in the eye, the retina is the most distal part of the visual pathway we talked about. So if you get punched in the eye, it's much more likely to cause retinal detachment and affect the optic nerve. But I know that confused some students, so that's why you got a bunch of bonus points. Hope this made you laugh, and I hope you got it right. I think everybody got it right. Which ganglion does the parasympathetic fibers travel through? It's going to be ciliary ganglion. Celiac was, remember that was like T5, T9. That's like sympathetic control of the foregut. Otic ganglion is cranial nerve 9. Innervates the parotid gland. These two are cranial nerve 7, and they go to all the other glands, or innervate all the other glands. Broca's area causes injury to Broca's area causes the inability to speak. So answer is C. B would be describing Wernicke's area. Swallow would be an injury to cranial nerve 9 or 10. This is something interesting. It's called prosopagnosia, and it can result from damage to a visual association area or a parietal lobe stroke or something like that. Chewing muscles and mastication, I think, are like V3, cranial nerve V3 injury. Anyway, the answer is C. Color vision for cones, 50's A. Bonus. Everyone got this right. Good job, guys. Also, I've been getting into ETFs lately. Been studying some ETFs. They're kind of like, sort of like mutual funds, but way more risky, and they compose of like 100% stocks. But maybe I'll include a slide on ETFs next system. 2, I think a decent amount of you got this right. Good job. This is called Alpha Storm, and it happens when you treat somebody high on cocaine with a beta blocker, and all this excess, like catecholamines, go to the alpha receptors, and specifically alpha 1 gets like way overstimulated, and then you get vasoconstriction, and not good. Third leading cause of death in the United States is medical error. You guys believe that? There's heart disease, cancer, and then medical error. So yeah, pretty crazy stuff. This was asking what the DRG is. It is pseudo-unipolar neuron. Which of the following would cause an increase either directly or indirectly in adenyl cyclase and cyclic AMP? So, first of all, you know you can cross out anything that is GQ. That's like have one M&M. So alpha 1's GQ, M1's GQ. Beta 1 and beta 2 are both GS. So if you inhibit GS, you are going to cause a decrease in cyclic AMP. So neither of these are right. The answer is F. M2 is GI coupled. So if you inhibit something that's GI coupled, you're going to indirectly allow for the increase of cyclic AMP adenyl cyclase. Number 5, guys, our entire existence is a hallucination. A couple of you got that right. But that was kind of just testing to see if you were paying attention to my rambling during my vision lecture. So everyone did a really good job, I thought, especially given a bunch of new information. I won't be handing these exams back just in case I use these questions next year, which I'll probably use some of them. What else do I want to say? Oh, remember this stuff, okay? Like, watch this and consolidate it. And, you know, if you didn't do well on this test, your attitude following it can, like, you know, make a difference between success in medical school and failure, because the real learning takes place from failing and then going back and look, okay, why did I get this wrong? I saw several of my classmates do this. If you have an attitude of failure followed by like getting down yourself, giving up, complaining, then that just results in more failure, right? Because then you never actually go back and look, okay, like, why did I get this wrong? What areas am I weak on, etc., etc. So I will see you guys in the respiratory system. Good luck with renal and GI. Just a heads up, I will ask future questions on some cumulative material, but only if it relates to the system we're learning. So like the respiratory system, if there's something that integrates neuro, you know, I will ask integrative questions. Only a handful, like not very many, but just a heads up. All right. Well, let me know if you have any other questions about the test or your grade or anything like that. If you do want to look at your test, you can come see me and look at it. You just can't keep it. I think that's it. Great job, and I will see you soon.